Now, if I wanted to move to a different angle, let's say, let me erase this. 17 is always going to be my hypotenuse, so I know that isn't going to change. But let's say I wanted to change things here and say I wanted to find the sine of r. What that means is I would have to go to angle r. I'm sorry, we're not going to do r. We're going to do q. You're not going to have to do r today. Let's go to q. So I'm going to go to q. The opposite would now be 8 because it's directly across from angle q, and now my adjacent would be 15 because it's adjacent because it's making up part of angle q. Sine is O over h. My opposite side is 8. My hypotenuse is 17. And once again, if you take 8 divided by 17, you get 0.4706. So just make sure you look at the angles that you're working with so that you set up your opposite and your adjacent correctly. Okay, in the next example, we want to find the cosine of A to 4 decimal points. Well, the first piece of information I know is that cosine equals A over h. And what I want to do next is I want to go to angle A. I'm going to go to angle A. I know directly across from angle A is the opposite. So the opposite side is 2. I know that root 3 is adjacent because it makes up part of angle A. And C has to be the hypotenuse because it's directly across from the right angle. Okay, now when I look at this information, I think, well, the hypotenuse is missing. We don't actually have a number for the hypotenuse. So we're going to have to come up with that. And the easiest way to do that, and the most logical, is to use the Pythagorean theorem because you have a right angle. And if you know 2 of your sides, you can very easily find the third side. So to find the hypotenuse, I'm going to use the Pythagorean theorem of a squared plus b squared equals c